Hello, everyone, and welcome to another Advent of Code in Kotlin stream. As you can tell, the setup is slightly different today. We're in a little bit of a different location, and I'm also, right from the get-go, I'm not alone, and I'm here with Martin. Hey, Martin, how are you?
Hey, I'm doing great. It's excellent doing this live.
Right? We could probably tell a bunch of very interesting stories about what happened just before stream.
Nothing interesting happened just before stream. You're seeing all the important bits.
That's right. Everything is just as it's supposed to be. As usual, welcome, and thank you so much for deciding to spend your afternoon, day, morning, whatever it might be, with us here, doing a little bit of Advent of Code. So, if you are currently in the chat, make sure you say something. Make sure you maybe give us a little wave or a little hello, and maybe let us know how you felt about today's problem. Now, besides myself, I can give a little bit of spoiler here. I actually had to say I was a little more afraid than maybe I had any right to this morning. I don't know how it was for you.
I was as well. After day 5, I was worried about solving the puzzle today in time so that I can actually bring solutions to this stream. I was also traveling, a bit of like behind the scenes info. So I was trying to solve the problems like at an airport today. But luckily, I think we had a friendly problem for day 7.
A travel-sized problem.
A travel-sized problem. Yes.
Yeah. So you're currently, in case you're wondering where we are, we're both currently in Munich, and this is part of the JetBrains offices. They don't usually look like this. This was the work of rearranging a bunch of furniture and putting a bunch of lamps in in different positions. But I think it puts us in a nice and cozy place that has the exact kind of vibe that I like going for in Advent of Code.
You could say that it's a nice setup.
It's a nice setup for the things that we will be doing, so to say. Yeah. So we have a couple of comments here. Jonathan says, I messed up today hard, took ages to debug sorting. Yeah, that definitely happens. The background is not fake. No, this is very real. I could throw
Should I move something?
Yeah, sure.
We can do this.
Yeah, look at this. So we can recenter the the Christmas tree. So yeah, no, this is all real. So Martin, we're gonna be talking about today's Advent of Code quite a bit, but I'm actually curious. Like, do you have any background with Advent of Code? Have you done it before in the previous years? I have seen that you've done the challenges this year.
Yeah, so far I've managed to complete the challenges this year. I think 2 years ago, I think I've completed everything.
Wow.
On the last couple of days with a lots of headache and a lot of reading other people's solutions and explanations. But I did eventually code it myself, and I had a working solution written by myself in Kotlin. So that was good enough for me. Yeah, and then last year I was on one of the days of the live streams.
That's right.
Yeah, and then I think 2 years ago when I really started doing it.
Mm-hmm.
And at some point I went back and did a couple puzzles from earlier years, just to have more fun with it, because it's a lot of fun going through these.
I guess going back to a couple of previous years maybe takes out the little bit of the stress of being okay, this is today's challenge. It should be done today.
I mean, there's a lot less stress if you don't have a live stream that you have to be on in the evening where you're supposed to solve these.
That certainly also adds to it while you're traveling and while you're on the airport. Yeah. So before we dive into today's problem, I do just briefly want to actually share a couple of news which came out earlier today, and that's that Kotlin for WebAssembly actually got promoted to alpha, which is quite exciting. I mean, Kotlin for WebAssembly, we're gonna be doing a bunch of interesting stuff with it. Me personally, I'm mostly excited about the compose stuff, but I mean, there's a lot to that. We can do like WebAssembly even like outside the browser, which, yeah, kind of neat.
Yeah, I do enjoy running compose on WebAssembly. So I have an unpublished pet project that I'm working on, like on the side, which is building some web UI for task management and compose with WASM.
Oh, nice.
And I gotta say, it's really nice reusing all of the things that we know from compose, but building it on the web. So just rows and columns and animations, and it's just nice.
Yeah, no, it's certainly a good time having this kind of reuse, and I do hope that on the upcoming streams that we'll have, there'll also be a little bit of Kotlin for WebAssembly visible. So if you are interested in this, like Maya, who says, "Oh no, I have another thing to learn now," if you are interested in this, make sure that you also tune in for the following days. This is the folks that are around by now, by day 7. I'd probably describe you as the loyal crowd, so I would assume that maybe you'll tune in again tomorrow. If that is the case, make sure that you do check the timestamp, because we will be starting a little bit, or actually a couple of hours earlier than usual. And the reason for this is because we're going to go celebrate, because it is Christmas time, and it is time to also have a Christmas celebration for us, which will happen in the afternoon. So our stream, of course, we're not letting you alone here, but the stream is going to happen a lot earlier in the evening, or afternoon, I should say. All right, great. Well, with that, I think we can probably just dive into today's challenge.
Yeah, let's see it.
So let me just bring this one up here, and we can start the dramatic reading portion. And that reading portion is, of course, not complete without someone complaining about me not wearing the hat. So let me just make sure I untangle that. There we go. That's all set. All right. Okay, look at that. Looking good. We got a new contender here.
You can still do the reading, though.
I still get to do the reading. That's nice. That's delightful. Okay, today we are looking at day 7. Camel cards. Your all expenses paid trip turns out to be a one-way 5-minute ride in an airship. At least it's a cool airship. It drops you off at the edge of a vast desert and descends back to Island Island. Did you bring the parts? You turn around to see an elf completely covered in white clothing, wearing goggles and riding a large camel. Did you bring the parts? She asks again, louder this time. You aren't sure what parts she's looking for. You're here to figure out why the sand stopped. The parts for the sand, yes. Come with me. I will show you. She beckons you onto the camel. After riding a bit across the sands of Desert Island, you can see what looks like very large rocks covering half of the horizon. The elf explains that the rocks are all along the part of Desert Island that is directly above Island Island, making it hard to even get there. Normally, they use big machines to move the rocks and filter the sand, but the machines have broken down because Desert Island recently stopped receiving the parts they need to fix the machines. You've already assumed it'll be your job to figure out why the parts stopped when she asks if you can help. You agree automatically. Because the journey will take a few days, she offers to teach you the game of camel cards. Camel cards is sort of similar to poker, except it's designed to be easier to play while riding a camel. In camel cards, you get a list of hands, and your goal is to order them based on the strength of each hand. A hand consists of 5 cards labeled one of AKQJT98765 4, 3, or 2. The relative strength of each card follows this order, where A is the highest and 2 is the lowest. Every hand is exactly one type. From strongest to weakest, they are 5 of a kind, where all 5 cards have the same label, like AA, AA. A. 4 of a kind, where 4 cards have the same label and 1 card has a different label, like AA8, AA. Full house, where 3 cards have the same label and the remaining 2 cards share a different label, 2, 3, 3, 3, 2. 3 of a kind, where 3 cards have the same label and the remaining 2 cards are each different from any other card in the hand, like TTT 9, 8. 2 pair, where the 2 cards share one label, 2 other cards share a second label, and the remaining card has a third label, 2, 3, 4, 3, 2. 1 pair, where 2 cards share one label and the other 3 cards have a different label from the pair and each other, A23, A4. And high card, where all cards' labels are distinct, 2, 3, 4, 5, 6. Hands are primarily ordered based on type. For example, every full house is stronger than any 3 of a kind. If 2 hands have the same type, a second ordering rule takes effect. Start by comparing the first card in each hand. If these cards are different, the hand with the stronger first card is considered stronger. If the first card in each hand have the same label, however, then move on to considering the second card in each hand. If they differ, the hand with the higher second card wins. Otherwise, continue with the third card in each hand, then the fourth, then the fifth. So, 3, 3, 3, 3, 2, and 2 AA, AA are both 4 of a kind hands, but 3, 3, 3, 3, 2 is stronger because its first card is stronger. Similar 7, 7, 8, 8, 8 and 7, 7, 7, 8, 8 are both a full house, but 7, 7, 8, 8, 8 is stronger because its third card is stronger, and both hands have the same first and second card. To play camel cards, you are given a list of hands and their corresponding bid, your puzzle input. For example, a couple of hands. This example shows 5 hands. Each hand is followed by its bid amount. Each hand wins an amount equal to its bid multiplied by its rank, where the weakest hand gets rank 1, the second weakest hand gets rank 2, and so on up until the strongest hand. Because there are 5 hands in this example, the strongest hand will have rank 5, and its bid will be multiplied by 5. So the first step is to put the hands in order of strength. 3, 2, T, 3, K is the only 1 pair, and the other hands are all a stronger type, so it gets rank 1. KK 6, 7, 7 and KT, JJT are both 2 pair. Their first cards both have the same label, but the second card of KK 6, 7, 7 is stronger, K versus T, so KT, JJT gets rank 2, and KK 6, 7, 7 gets rank 3. T55J5 and QQQJA are both 3 of a kind. QQQJA has a stronger first card, so it gets rank 5, and T55J5 gets rank 4. Now you can determine the total winnings of this set of hands by adding up the result of multiplying each hand's bid with its rank. 765 times 1 plus 220 times 2 plus 28 times 3 plus 684 times 4 plus 483 times 5. So the total winnings in this example are 6,440. Find the rank of each hand in your set. What are the total winnings? That was quite a mouthful, huh?
That was a very long puzzle description.
Oh my.
Also, the hands lend themselves really well to being spoken out loud.
Right? That's what I was thinking. I have to say, it's a little bit of a different experience saying this out loud with an audience next to you somehow. There's just a different fare to it where it's like, am I really just reading out 6 different types of cards?
Yes.
But we got through it. This is all fine. So, Martin, you solved this problem. this morning.
I think I did. Yeah.
We hope so. We hope you solved this problem. You did this in the taxi, on the go somehow.
On the go. Yes.
On the go. We'll say on the go. So what were your thoughts here when you encountered this problem?
So as I read this in the morning, first of all, I was relieved because it didn't look that bad. Of course, anything can happen in part 2.
Yep.
But the base problem description seemed fine. So we had to parse all of these hands. We have to do a bunch of sorting, but that's just putting things into collections and wrangling them a bit, which is something that's really nice to do in Kotlin. So I was like, we can use a bunch of collection functions. We'll have great tools to use, and it should go okay. We have to be able to decide which type each hand is. So if we have, 4 of a kind or 3 of a kind or pairs or things like that. But that seemed like it's fairly easy to do because we can just count how many of each character we have and then find the patterns in it. And finally, there's this sorting part. And actually, I had an idea for how to do that quite quickly as well, but we'll get to that.
Okay. Now you did say, and I think it's very fair, that usually anything goes in part 2.
Yes.
So
yeah.
Looking at the problem statement, did you have a specific fear for part 2 or something that you anticipated when you approached the problem?
Not really. I think I had no idea what part 2 is going to bring. Yeah.
All right.
I didn't have any guesses based on part 1.
Yeah. I mean, when we take a look at the input here, we can also kind of get ourselves a little bit of an idea of kind of the size of what things are happening. The bets aren't particularly large. You do multiply them by the rank, but this whole thing seems to have around 1,000 lines of input, which doesn't seem like it would explode too crazily.
Which was also a relief. Yeah.
Yeah. That wasn't too crazy. The hands are always constrained to be only 5 elements long. So this was all a matter of parsing 5,000 hands and ordering them.
And the parsing wasn't too bad either because we didn't have commas and semicolons and 5 different separators and we had a day where we had to do a lot of parsing this year. I don't know which one it was, but
yeah,
it seemed friendly. It's
potentially deceptively so. Who knows? Shall we just dive into your solution then?
Yeah, I think we can do that.
Wonderful. So you picked Fleet as your tool of choice for today. So we're gonna hop into that. And I'll clear up a little bit of our screen here. And of course, just like the previous days when we were using Fleet, we are just using the integrated collaboration functionality that's built in. So even though we're physically in the same room and Martin could just reach over, this is possible. We're not doing that. I'm very territorial about my laptop. He instead gets to join remotely and work on the exact same code and show the same things off right here. And of course, we are also doing this in our little behind-the-scenes project, which also uses Amper. Maybe we'll talk about that later. Who knows? So, with that, do you want to start us off?
Yeah, let's see if I can explain this in a sensible way. So first of all, after completing both parts, I've refactored things because the solution is essentially the same with just slightly different parameters. So part 1 is going to look quite odd looking at it on its own because we just have a solve function here, which takes all of the input that we're going to parse. Then it has the ranks of the different cards, which I've just copied from the problem description. I've removed the commas in between, and then I reversed it. Of course, I could have actually reversed the string, but since I was copying this is how they were listed. So this string that we're passing in is the ascending order of the different cards by strength, then for good measure, we have a bit of the alphabet here.
Always useful, but only up to M.
Only up to M, yes. So
okay.
So this is the solution I came up with for sorting the cards alphabetically after we figure out what types they are.
Okay.
Because after we have that, we have to sort by the ranks of the cards. And we have to check the first card, and if those are the same, we have to check the second card, and if those are the same, we have to check the third card. And if these were only digits, this would work by just sorting the strings, right? Like if they were just numerical digits, we could just sort the strings and not have to do any custom logic at all.
True.
But we are in base like 15 or whatever, however many digits we have here. So we have more things than just digits. So I figured that I can just map all of this to letters, which will sort themselves.
So kind of like poor man's hexadecimal, but just like, okay, sure, base Marton.
But in the simplest way that I could think of, which was to just use letters, which will sort correctly if you sort strings.
That already sounds like a wonderful hack. I'm already curious here.
And then we have one more parameter to solving the puzzle, which is to determine the type of a specific hand. So if we were to actually type out the parameter here, then hopefully you have inlay hints enabled, which I don't. But on the stream, we can see that that's an incoming string, which is going to be the 5 characters of a hand, so the cards that we have. And so this parameter will extract the type of the hand so that we can also sort by that before we do the sorting based on the individual cards in the hand. Does that make sense so far? Kind of?
I'll go with sure. It sounds close enough. Maya calls your base a half alpha base, which I think is nice. Also,
wait, is it exactly 13 letters actually? I guess it is.
Oh.
I'm not gonna count that.
Does it not show that in the corner down there?
It doesn't show the length of the selection.
No, it doesn't.
But if you're willing to do the math on 38 minus 25, I think that checks out.
It's 13. Yes. Great. Look at that. Yeah. Also, you're getting called out for your classic developer laziness, which I assume is the reversed, like letting the machine do it instead of you doing it once.
Also, Maya says that if you just know cards, there's 13 cards in a suit, which, yes, there are, which, because we're just using a regular deck of cards here, except we're on a camel.
Yeah.
Okay, so this is the setup. This is the parameters we're passing in. So let's see how we actually solve this. So I have a helper function up here, which is for parsing the input. This turns our list of strings into a list of hands. If we scroll all the way up here, we can find the implementation, and I can already see that this is way off screen on your end. So I'm gonna split this into a couple lines. So we have hands here, which is a data class, holds the 5 characters of cards that we have and the bid associated with it. And then parsing it is splitting it by the space in the middle of the line. And then we convert the second part of that to an int. So far, we're just putting things in data classes.
This part I'm fine with.
Thank you. Next, we do the sorting. So essentially, the entire puzzle was sorting by one thing first, and then if that doesn't distinguish the cards enough, then sorting by another thing. So we sort by the type first, so whether it's 2 pairs, 1 pair, and so on. And after that, we sort by we sort alphabetically, if you ask me.
Yeah.
So we sort by the strength of the first card and then the strength of the second card and so on.
Mm-hmm.
And for this, I was really, as I mentioned, lucky because like what I thought at the very beginning looking at this, which was like, we have all of these great collection functions that we can use. we could indeed use those great collection functions. So we have sorted with here, which takes, I believe, a comparator.
I call it comparator. But who knows?
As a parameter. We can roll with that.
Someone can post the IPA in in chat and we'll still not be able to read it.
Perfect. So we can pass in an object that allows us to compare the items in our list. And we also have the compare by function, which allows us to create one of these comparators easily. And what this takes as a parameter is a var arg of different selectors. So we can select, we can extract values from the list of items that we have with the first lambda, and then it will compare those values. And then we can pass in additional lambdas that it will use for additional comparisons if the first lambda just gives you the same value for multiple items. So in this case, if multiple cards yield the same type, so for example, if two different cards give you like, I don't know, 2 pairs, then it goes on and it runs the second lambda on those cards as well and differentiates it based on that one. Okay, so let's see how we do the types. So really, for the type comparison, we just need to return some value to the comparator that is sortable, so that can be compared to one another. And that will put the more valuable cards higher up than, well, the more valuable hands of cards higher up than the less valuable ones. So for this, I have a type function up here, which does exactly that. So first, we group the input string that we have by its letters, and then we do an each count on it.
I'm very sorry. The reason why I'm laughing is I can see a couple of things here from my own solution being done nicer than my own solution. So I'm very excited to get roasted later on. Do continue, sorry.
We'll be able to compare later.
Sure.
So grouping by an each count gives us, let me check the types here, gives us a map of characters to ints. That means that we have a map where it contains whatever characters were in the string, and it will contain how many times those were present in the string. But I actually only need to know the counts here. So for example, I don't know, let's make up a hand. So like AA, I don't know, 323. Like
sure,
this.
2 pairs.
So for this, it would give us a count of 2 and 1. So we would have 2 A's, 2 3's, and a 2. So we would get something like this out of this value score. And we just have to look at this list, and based on how many times we see whatever value is occurring, because we're not checking what those cards are that occur this many times, just that something occurs 2 times, we can determine what we have. So if we have a 5 in here, that actually means that the entire list is just a 5. Then we have a 5, which we've identified. And if we have a 4, then we have a 4. And if we have a 3 and a 2, then that must be a full, because we have 3
Makes
of
sense.
a kind and a pair.
Yep.
If we have 3 of a kind, that's a 3. Then here was the part which I've managed to really overcomplicate and initially break in my implementation. Initially, I tried doing this with sets. I'm not going to type that out. It was really bad. It actually doesn't help at all. It's not a teachable moment to type it out.
I have a weird feeling we might still see this, so we'll go on.
So here I was trying to check if I have 2 2's in here, and I didn't find a super nice way to check it. Maybe chat will help out here. But you know, I was trying to see things like maybe counts contains all of like a list of 2 and 2. and then that's a 2 pair or something like that.
Mm-hmm.
So I was trying things like this, but this of course will be true for any list that has a 2 in it, because the checks are individual, and this doesn't check that 2 is contained twice. So I gave up on those approaches, and what I did is, if 2 is in the list, then I go ahead and take 2 out of the list. So this removes the first element in the list that's a 2.
Okay, sure, that's fine.
And then I check if 2 is still in that list. Actually, we can make this a lot harder to read now that I realize
2 in counts minus 2.
We can just check like this. I don't know if this is better or worse. I kind of like it.
It's elegant in a weird way. I mean, at least now that I feel like the pattern is still kind of okay. For me, working with collection of primitive numbers and doing like -2 that's like always a little scary. Yeah.
In the chat, we see some ideas about using the size. Actually, that would be probably a good idea. So if we have a 2 in the counts and the total size of the list is 3, then we must have another 2, right? I feel like that's
yes, right. That sounds about right.
Do we still have the assertions down here? I think we can just try that. Let's just duplicate this, and instead of that ugly check, if we have a 2 in the list and the list is a length of 3, well, I think we broke part 2 somehow, but part 1 checked out.
So
which is scary. So let's abandon this approach. Because in part 2 I start doing workarounds. So yeah.
Okay, cool. So I see that you have built on a solid foundation here.
Yes,
as we all do.
So yeah, that's how you determine a 2 pair. And if we didn't clear any of those conditions, and if we have a 2, then we have 1 pair, and anything else is just a high card, right? So we've determined this.
Mm-hmm.
I've also said earlier that these values here just have to be something that's sortable, and where 5 is going to be larger than 4, and 4 is going to be larger than full, and so on.
Yeah.
And we could I could have somehow used an enum here and used its ordinal value or something like that.
Yeah.
I really just gave up, and I just assigned numbers to these.
Great.
I initially went with 1, 2, 3, 4, 5, 6, 7.
Mm-hmm.
So like 5 was equal to 7. Then I switched to prime numbers because it looks a lot more interesting.
Not for any like actual application, just because it looks more interesting.
Yes.
I feel like that's a good move, because immediately I'm like, oh, of course he exploits the fact that he will later on be able to multiply these together and and extract the individual prime factors back out of that multiplication.
Exactly. We can also do powers of 2.
Yeah, that makes sense, because then you can shift them if you need to. Yeah. Okay.
We could actually. That's a clean solution to having a pattern of numbers. So we can start from 1. We can do 1 shift left. We can do 1 shift 3. And these do give us different numbers that are increasingly larger. Again, there's no practical meaning behind this whatsoever.
Yeah, I think we're just going off on a bit of a tangent here.
Yes. So all that I need for these values to be some kind of comparable values, and 5s have to be worth more than 4s, and so on and so on.
Cool.
This also works.
I feel like this one might still be most understandable.
Let's see if we broke it. We didn't break it.
Look at that.
So any combination of numbers here that allows us to sort these types is correct. Okay, let's keep moving.
Yeah, Johnny says there must be a way to set them using recursion.
There must be.
Yeah. Well, just use set theory. Just use sets of different sizes.
There you go. There's someone who's used from -1 to 5. So there's.
I'll let you in on a secret.
You did too.
I did too, because I started at the top and I was like, this seems like it's 5 numbers. I'll go 5 down to like 0, and then I hit 0 and there was one more case and I was like, now what? Like, well, I guess I can do -1. I just need to sort them. But then I was like, this looks a little brittle. So you're not alone.
Okay, so any values. Okay, so
if
that's
only Kotlin had enums. Oh wait.
If only. So that's the first comparison, right? We sort into large groups based on the type. So this would put all of the high cards to the start of the list. Then it would have all of the 1 pairs and all of the 2 pairs and so on and so on. But within those types, those larger categories, we also need to sort by card order, right?
Yeah.
So like by the first card's value and then the second card's value and so on. Let's maybe, okay, here's what we're gonna do. We're gonna alphabetize 2 things. We're gonna print some of these well, that's just printing it. So we're gonna print some of these conversions, and then hopefully it will. Of course, all of these are gonna be sorted, but hopefully this will give us some idea of what's happening here. So if I just grab those, okay, then we can see what this alphabetized function I have is doing with the mapping. So as we've seen, can you scroll down just a little bit?
Can we just okay? First of all, can we just start putting like maybe this one in here?
Yes.
What would you like to see?
Yeah, that works. Yeah. Again, what I'm really doing here is I'm mapping all of the characters that are in this string into these. So I'm just mapping like straight between these strings, except this one is reversed.
Okay, so you're mapping 2 to A,
yeah,
3
so
to B.
If I were to type this out actually reversed, I'm doing like this, and then T, J, Q, K, A, which I was refusing to do earlier.
Okay.
So I'm mapping 2s to that and 3s to B and so on. And if you look at this, that checks out. So the 4 becomes a D, and so on and so on. So basically, any string like this becomes a string converted into just letters, and the letters further on in the alphabet are the more valuable cards. So the M, which is the furthest from the set that we have, is going to be an ace. And so if we sort these strings just by the regular string sort, like natural string ordering, then that will do exactly what the exercise wants us to do, which is that we're comparing by the first letter, the first card's value, and if that's the same, then we proceed to the next one and so on. Like this is just alphabetical sorting.
Okay.
At this point.
Yeah.
And that's what this alphabetized function does. So it takes each character of the string, it goes into the alphabet that we passed in, and just indexes into it with the same index that we had in the original string. So we find that we're like, maybe if we have a 9, we find out what index that's at, and then we find the corresponding index in this string.
Okay.
And converting all of the cards into this alphabetical representation, again, like just works. And from here, we have all of our hands. So we have this list of hand objects, and we have it sorted by rank. We're calling these ranks in the Kotlin description, right?
Yes.
And so all that's left to do is do the math on, I don't know what the description said anymore.
The bids.
So
rank times bid.
Calculate the winnings.
Oh, the winnings.
Yeah. So, and the winnings are bid times rank, and we have all of the cards sorted here in ascending order, because we use sorted by and not sorted by descending, which I feel like should exist. Sorted. Oh, there's no sorted with descending. There's just sorted by descending. There's a feature request for the standard library.
Interesting.
So yeah, we have an ascending order. So the most powerful hand is at the very end, and we can actually check that in the output if you still have
Just wondering if I could Okay.
You could reverse the comparators.
Yeah, that's kind of what I was going on. Sorry?
So if we... Oh, actually, we're not printing that. No, never mind. So basically, we have the strongest cards at the end. So the highest rank is at the end. And because we're 0 indexed and the ranks go from 1 to 1,000, because we have 1,000 hands, we need to add 1 to each of them and then multiply by the bid. And finally, we sum up all of the values.
Okay.
Seems like this is maybe just a sum off.
We don't have sum of indexed.
We don't have sum of indexed, another feature request.
Sure, but at some point, you are allowed to use more than one function.
That's true.
That is okay. If you don't want intermediate collections, you can, of course, just convert these to sequences if that's
Could have been a sequence all along.
Your concern. Yeah, that is a very approach, I have to say. So far very compact. Was this your first draft?
Yes, I mean I cleaned it up a bit so that it's more readable, and I extracted it so that it solves both parts with parameters, because we need to change around some of the things for the second part solution. But the idea that I'm going to check the types by doing the each count and then looking at the values in there, that's what I started with. And I also quite quickly had this initial idea of just trying to alphabetize things. I don't know where that came from, but as I was reading that the comparison first compares the first thing and then the second thing, it just sounded like we're comparing strings, and I was really tempted to try to just put whatever card information we have into a string that will sort itself.
So and actually, this is once again the point, because we do have a viewer pointing out that A is greater than K is greater than J in the cards, but of course not in the other direction. But that's a matter of this step of alphabetization, I guess, that you've done, because you have assigned the variables the correct ordering, or sorry, you've assigned each card symbol the proper the proper alphabetical symbol that sorts correctly. Sorting in either direction would work.
Yes, I think we should be able to reverse that. I don't really want to do it live.
That's perfectly okay.
But we could probably make that workable. And yeah, the fact that these are letters and that it's an alphabet parameter is kind of besides the point. If I could have just done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 as digits in a string, I would have done it. We just don't have enough digits. So I was like, the alphabet has a lot of symbols that I know for sure are in an order when we sort them.
No, but I do actually think about it now. So if you could have done hex, actually, right? Like you could have done like 0 through 9 and then A through A, B,
maybe
C.
I mean, we can try that. So just 0 through 9. I'm sure I got that right. And
so that's 10 and then ABC.
Need just ABC.
Yeah, that sounds like it will be correct.
I think I got all the digits. So if we run that, that's indeed correct.
Cool.
So hex works.
Hey,
so
look at that.
If you're comfortable enough with ASCII that you know that lowercase letters come after the numbers.
Yeah.
I did not Google that, and I did not know it off the top of my head.
I'm not sure if it makes it more approachable, but I mean, now at least now it becomes clear that the transformation you're doing is just we're interpreting it as base 13 numbers.
Yes.
And
that's nice.
And then sorting them.
We can also make these uppercase, I hope.
I sure would hope so. Great, wonderful, awesome. So now we just have to figure out an emoji ordering that also works.
I'll leave that as an exercise to the viewers.
Sounds like a great idea. Yeah, Casper actually says that they did hex in their implementation, which that makes sense.
Yeah.
Rob says that it did seem like map followed by sum is much slower than SUMOF in one of the previous assignments. Now that's very interesting, because it hopefully shouldn't be too much.
So the only extra work you're doing is creating one more collection.
Yeah, so if your collection becomes big, that might be a problem, but if
it would have to be very large for you to be able to see that it's slower. Right?
Yeah, I mean,
I don't know if you're benchmarking it.
Yes. The question is, of course, what is much slower? Is it 200%, or is it 20 milliseconds, or is it 2 minutes? But also, the important part that you always have to keep in mind is that, yeah, if you're just doing a map on anything, like if you're doing a map on like a range and then using that result for something, you will have materialized that entire range. So if you have a range from 0 to like 2 billion, and then you create an object for each of those, you now have 2 billion objects in memory, and you have to work with that. 20 milliseconds versus 1 second.
That's huge.
That is huge. That sounds like you're probably... Why don't you try squeezing an as sequence call before you do that map statement? Because I feel like, again, if you're doing a map and then a sum off, there's no reason for you to allocate and then keep in memory all those objects and then clean them up later. But that is a very interesting case. And definitely one that requires a little more like looking into.
I'm also curious about how large that map was.
Yeah.
That list that was being mapped. Yeah.
That's quite curious. Okay.
So that's a solution to part 1.
That is a solution. I'm personally, I would have been very happy with the solution. I think it would actually be more fun if we looked at my solution right now, because so I do have, I kind of took this approach that we saw on our stream with Dima on Monday, who was like, well, to do part 2, we'll just copy the first part, we'll mutate it around a little bit. Again, this is just, it's a different part of the challenge. Sometimes it's really nice to build an abstraction that works for both parts. Sometimes that might be overkill. Sometimes that might just not be what you want to do. Sometimes you really just want to have breakfast. All of these are perfectly valid reasons, at least in my opinion.
Sometimes you need to board in between.
Yeah, exactly. Like the nice lady will tell you, like, please close the laptop, and you're like, just quick submit, something like that. Who knows? Okay, so I hope you're braced. We'll look at my solution here. A lot of things here. There's already an unused variable. I did not touch this code. I did not touch, and I didn't clean it up in any way. So that's kind of where we're at, and we're at a cool 90 lines of code. Not a problem though.
Is that both parts or the first part?
That's the first part. But to be fair, the second part has just a couple of it's essentially the same code with a couple of adjustments.
Sounds good.
The first part that doesn't really need to be really discussed is how we create our original list of plays, which is just really creating data classes again. Because I didn't want to bother with adding a second line, I used the semicolon here, which is probably a little overkill. So we'll put that back in its place ever so slightly, so it's slightly more readable.
It's the exact same code as mine. There's a different class name, but
yeah. And apart from that, and you'll see that even the second part is kind of the same as yours. The only difference is that I decided, rather than taking the individual hands and sorting those, I just decided I'll make a whole play essentially. So these should really be called plays.
Yeah.
We can rename these.
I'll let you in on a secret. I used the exact same naming initially. So I had plays which had a hand and a bit in it, but then I tried to align more with the puzzles naming, and I ended up naming the class a hand because apparently the hand contained the bit, and I went to cards for the property name. But
how are you gonna hold all the cards and the bit in the same?
There's only so many hands you have.
Yeah, exactly. And I feel like to look cool, you'd have to do it with one, which is always troublesome. Plus it's hand singular, not hands plural, right? Anyway, so we're getting perfectly off track. This code we've already seen apart from this. Like the ranking logic, it works the same. You multiply it, you first do a map index, and then you do a sum because there is no sum of indexed. Nothing new here. You'll notice that my code for actually creating the stuff looks a tiny little bit different. And probably
there's a bit of unused code.
Yeah, there is a little bit of unused code here. That's okay though, because sometimes you make a couple of refactorings and you don't clean up after yourself because you've moved on to a second part.
A quick question.
Sure.
Do we actually need to call those functions there without using the return values?
Oh, no, that's why they're gone now. Oh, they're not gone.
No,
yeah. My bad. Yeah,
okay. Yeah. I was a bit
There's
scared that we might have to do that.
Oh yeah, no, this sets up all the mutable states for later on for the big reveal. No. So I also essentially just decided, first of all, I decided since all of these are objects that I want to compare directly, I'll have the play class implement comparable, because then you can just call sort. You don't have to like specify which comparator to use.
Makes perfect sense.
Yeah. And then we'll see here that the compare to function does the exact same two things as yours, right? First, you take a look at the strength comparison, which is you figure out the hand strength for each one of them, you compare them. If that hand strength comparison is not equal, then we can just return the strength comparison directly. Otherwise, in my code here, I decided, okay, we're looking at each character and we gotta compare those. So I decided I'll zip them. I'll zip together my hands. So for each of the two hands I'm comparing, I'll look at each pair, and then for each pair, because they're strings, because they are strings, but they have a specific value attached to them, I use this intra-type strength variable, which is just like if the type of the hand that you have is the same, it's just the symbol value.
It's a comparison within that.
Yes, it's just a comparison within that. It's a very fancy name for this. The implementation for this, don't worry, it also has some weird stuff at the end here. Of course, this also just types out the not alphabet, but the actual cards here. Not sure what the nicest format for this is, but probably this.
It flat maps them into a list.
And then this, yeah. So what's happening here?
So you're using flat map here to go from strings to characters.
Yes.
Because
because I typed all of them out as strings, and I was like, I kind of need them to be characters. so I just decided I will flat map them. This is good enough. Don't do this. Don't do this in normal code. but it works, which is fine.
I think Seb is standard library flexing. It's an accurate description of what's happening here.
I think the actual accurate description for this is when I write my first solution, I'm very like append only. Like I'll write something and then I'll be like, I need to print it, so I guess we'll do apply print line or like also print line. And here I'm like, I typed it out. I don't want to go back. I'll flat map it. And so what this really does is, just in case you're not familiar with this syntax. So what this does is it interprets each input each string as a list of characters. That's always a single character, right? What you have inside here is always a list containing a single character. So if I were to just regularly map this, I'd end up with a list of characters. But since I just want the original character list, I'll use flat map, which unpacks all these lists, puts them in one top level list.
Do you want to show how you would fix this with multiple cursors or something like that? I'm seeing suggestions for this.
Sure. I can just go up here.
Use Alt-J and ideas like that.
Yeah, essentially this, and then just not doing any of this nonsense works perfectly. But then what would we have to talk about on stream?
Exactly.
If I had already fixed this, I'm okay with this. So yeah, and then at the end, so these are ranked in ascending order, and then I just look at the actual index, and that gives me the real strength, where ace is the strongest, or A is the strongest, and then 2 is the lowest.
Yeah. So this is how you map each character into an int, and higher ones are stronger. Yeah.
So nothing crazy really here. And I guess the only part that really becomes interesting now is how
zipping.
Is it? Is that the interesting part? So the zipping is just.
I want to. It is interesting, I think.
So it's just I want to know which is the first character that differs. So what do? I take both of my hands, I zip them together, so I always have pairs of like the elements as I go through them, and then I say, give me the first element of this where they are different. And someone has rightfully pointed out that the way I implemented this, when all of them are the same, this will just throw an exception. This comparator will just kind of break. Because, well, I'm asking for the first one where they're not equal.
And it will crash because you don't
and
have
it'll
the first
crash,
value.
yeah, so, and I could, of course, do like first or null or something like that, or I could introduce some error handling.
Or you could just compare at the very beginning if they're the exact same.
You could also
just
you could
special case that.
You could do that, or you could do my interpretation, which is the problem statement does not specify how perfectly equal hands of cards are handled when compared. Therefore, I see no reason. Like all I can do based on what the information that I was given is crash and burn.
Because they so if you would have the exact same hand multiple times in the input, they could have different bits, and you would have multiple possible end results, which doesn't make sense.
Yeah. So at that point, there's no real reason for me here to handle this case in any way gracefully.
Crashing sounds fine.
Yeah.
There's also a suggestion here that you could drop while A equals B. Probably.
That would work, but then you obviously don't get... that would also work.
That sounds fun.
You would get the rest of the list then, though. So you would still have to do dot single on that, I guess, which would maybe make the assertion a little bit clearer.
Yeah, you would have to grab the first remaining value.
Yes.
First or null would also work.
Yeah. Of course, yeah, you can use first or null, but then you have to handle it, and like if all I do is throw an error, I might as well just let it crash. And then the only other part, and here's where it gets a little, as if this wasn't weird enough yet, is how I determine the hand strength.
Of course.
Right. So let's take a look at that. So it's real simple. It's just
it makes so much sense.
It's just a mapping. And if I were a better developer, I'd maybe like actually name these like is high card, or like is one pair, or maybe is two pair, or maybe is three of a kind. Who knows?
You could also parse this into a sealed type and literally type check if it's a 2-pair or a 3-pair.
I could.
Then is could be a keyword instead of part of the method names.
That would be excellent. I could write a compiler plugin that just like emits this code.
You could.
Yeah. Does it make it a good idea? I don't know.
Hand should be something.
Yeah. Well. Tell me I'm wrong.
Hand should definitely be something.
Well, one of these conditions should be true. Otherwise, I'm in big trouble.
Yes.
If the implementation of is high card does not give me true back, that's just my sanity check of staying alive here. Now, how do we determine the different types?
I hope it involves enums, because chat is demanding enums yet again.
So we're not going to see any enums. We could do enums, but this is so. Remember, this is essentially my untouched solution as to like.
Okay, so surely 5 of a kind grabs the 5 characters of the string and makes sure that they're equal.
No. I turn it into a set, and then I check whether the cardinality of the set, so the number of items, is 1, which seems fine to me.
That's perfect.
Yeah, there's nothing really. That's about as short as a function can be. Is 4 of a kind. Now here is where it gets a little bit more interesting, because I'm like, so there's 2 different ways of how I can have 4 of a kind, right? In the beginning, it's in the end. So it's either if I look at the first, well, there's more combination.
Just to clarify, what's sorted here? Can we get that on screen?
Of course, we'll take a look here. So sorted is just my hands list sorted. Yeah. Okay.
So sorted by the character.
Yes, exactly. That's a very good point to call out, because obviously you have more than 2 ways of having four of a kind, you could have like the two in the front, two in the back. If you sort them, all you can have is, well, it's either the four in the front or it's the four in the back.
So it catches both, I don't know, something like this, and well, I don't know how the values go anymore, but
Sure.
something like this.
Yes, something like that. So it catches both of them. Great. So for the full house, we do a similar thing. But of course, now when we're sorted, we have a couple of different ways of how we can approach this, right?
Okay.
So in the sorted, the first three can be the same.
The middle three can be the same.
The middle three can be the same, or the last three can be the same.
Can the middle three be the same? Because for a full house, you would also want a pair. So whatever is in a pair would go to the front or the end, right?
You raise a good point.
I think if the middle three are the same, then the other two remaining ones would be different, and you would only have a three of a kind, right? So I think you can probably just skip the middle condition.
We probably can. We'll run this as is because this does give the correct solution, and then we can make that change after.
Makes sense.
Yeah.
And this is the same idea again.
Yeah, exactly. Is three of a kind takes the same kind of approach. We kind of feed it through. Is two of a pair is the first time where I was like, you know what? I feel like surely there must be a better way. Surely. And that's where even my sleepy self also discovered the delight that is grouping by each count. And in my point, I was just interested in, well, if two pairs means I need two entries of counts that have value 2. So I'll see, do I have, like, literally it's just, do I have two pairs? And for one pair, it's kind of the same thing. Is one pair is like,
there's two in there.
Is the size equals 1? Yeah, exactly.
And there's only one type of card that has two of them in the hand. Like you make sure that, yeah.
Yes. And for high card, it's the opposite of just all 5, which is just cardinality is 5.
There's something beautiful about the cardinality solutions. I wish all of the things in between could also be just cardinality checks.
Would be beautiful, but instead they're whatever this is.
Camel. What are we playing again? Camel poker?
Camel cards.
Camel cards is not so forgiving.
So it would seem. But yeah, we can. So I mean, I'll happily run your solution, and we'll see what kind of result we get here. So just so that we've done that for posterity, I suppose. And we get some kind of number like 25, 229, 5, 6, 7, 8. And you're more than welcome to run my solution.
Yes, I'll do that.
Well,
I'll find the main function.
These are the checks and balances.
Use the gutter icon, and
that is the same number.
It's the same number.
Look at that! Wow,
it's both wrong, probably.
It's as if there was some kind of web service system that has already previously enforced that we did the correct solution before we got a star.
It's almost like someone built that.
Crazy stuff. Okay, well, from there, I think we can probably go on to the second part. This is good. So let me just make sure I head on back here, and we'll see what the second part has in store for us, and whether we have programmed ourselves into a corner.
Indeed.
Hat goes back on. And we are ready for part 2. To make things a little more interesting, the elf introduces one additional rule. Now, J cards are jokers, wild cards that can act like whatever card would make the hand the strongest type possible. To balance this, J cards are now the weakest individual cards, weaker even than 2. The other cards stay in the same order. AK, QT, 987, 6, 5, 4, 3, 2, J. J cards can pretend to be whatever card is best for the purpose of determining hand type. For example, Q, JJ, Q2 is now considered 4 of a kind. However, For the purpose of breaking ties between two hands of the same type, J is always treated as J, not the card it's pretending to be. J, KKK2, is weaker than QQQQ2 because J is weaker than Q. Now the above example goes very differently. The first hand is still the only one pair. It doesn't contain any jokers, its strength doesn't increase. Hand number 3 is now the only 2 pair, making it the second weakest hand. T55J5, KTJJT, and QQQJA are now all 4 of a kind. T55J5 gets rank 3, QQQJA gets rank 4, and KTJJT gets rank 5. With the new Joker rule, the total winnings in this example are 5,905. Using the new Joker rule, find the rank of every hand in your set. What are the new total winnings?
Plot twist.
As usual. What were the thoughts?
So, looking at the solution that I had a very explicit place where I've ordered all of the ranks of cards.
Mm-hmm.
So, looking at that, that part seemed simple enough that I just shuffled around. I moved the J to be the lowest card, which was a very important part of the puzzle. It's even highlighted that J is now the weakest.
Yeah.
I think that was sort of easy to miss, but yeah, thankfully it was highlighted for us. So I knew that I had to move that in the ordering, and then I was solving this in my head as I was traveling, and what I was thinking is, whenever I have some hand to start with, so I have maybe, let's say that I have a pair. If I also have a joker that I can use, then I'm basically upgrading that pair to something more valuable.
Mm-hmm.
So if I have a pair and I have a joker that I can use for an upgrade, that will become a 3 of a kind. Or if I have 3 of a kind, that will become 4 of a kind. Or if I had 2 pairs, it would become a 4, right?
Yeah.
So that was my idea, that I can do this sort of upgrading using jokers. And I was really hoping that would work.
Mm-hmm.
I didn't formally verify to myself that this is how it works,
Mm-hmm.
but I figured I would code it and see if I'm right about it.
Okay. Yeah, for me, it was a matter of, it's like, easy. We can do a little string replace here, a little string replace there.
Just replace the jokers with
Yeah.
special values?
Yeah, sure. And then we'll go from there. But that turns out to not necessarily be a super great option, because if you just replace them all in the beginning, or if you just do a bunch of string permutations, what you end up with is the inability to then later on still treat them as their original values. So you can probably do some string transformations, but you have to do them in a more fine-grained manner.
So you would have to keep the original part of the hand, maybe have a transformed version where you transform the jokers to whatever makes that hand the most valuable.
I suppose that would be an approach.
Yeah.
Let's take a look at your solution, maybe.
Let's do that. So luckily, I've already refactored my solutions, right? So that it's the same function that solves both parts.
Yep.
So the solve function that we're calling into here is common. Let's compare what the difference is in the inputs. So if we take a look at the ranks, this was our original ranking going from 2 to ace, like this. So I've just moved the J to the very bottom of the list.
That's useful.
So that solves that part, that whenever we're alphabetizing, so whenever we're sorting by the individual cards within the hand, and using their order, J will now receive the lowest value and will be sorted, in my case, in the beginning of the list.
Yeah.
Because we're doing ascending sort.
Sure.
And then the other thing that had to change was that instead of just doing the type, now we have to do the type with jokers, right?
Sure.
It's as simple as that.
That's sure what it sounds like.
And so again, just to recap, we still have this solve function here, which does the same thing as before. The real difference is that here, as we're determining the type, so whether it's a pair, two pair, three of a kind, and so on, here we're now going to use this new function called type with jokers to determine the type of each card. So if we go to that, we can see that I've implemented this upgrading logic that I was mentioning, and it turns out that this does work.
Okay.
This does in fact solve the problem correctly. So first things first, our cards are going to have some base strength. So I've removed all of the J's and I've looked at what I would have if I had a hand without my jokers. So let's say that we have a hand like 2-2 JJ 5, something like that.
Yeah.
So here I would filter out the J's. So I would pass in just 2-5 to the original type function.
Yeah.
So this would tell me that my 2-5 string is one pair, right? So this would give me one pair here. And then I would count how many jokers I have that I can add back in to make my hand stronger using the jokers.
Yeah.
And so I go through the number of upgrades. This could also be repeat. Fold here is just flexing the standard library.
Of course.
I'm gonna actually show you what I've done. Originally, I started from base strengths, and then I did repeat upgrades number of times.
Which I'll be honest with you, I think might be actually the more approachable code snippet. But
yeah, so I had something like this here, which
just does the same body,
which is a lot easier to read.
Yeah.
But then I refactored into this. Because fold is cool,
but it is kind of like it's quite literally the same operation, right? It's like you start at your base strength value, and then you repeatedly for each
joker.
Yeah, for each joker you perform an upgrade.
Yes,
that's neat. I like that.
I was very happy that this idea I had actually worked.
That is very cool.
Yeah, and then how the upgrades work? If you have a 5 already, I think this never actually happens because then you don't have like this. We're trying to add like a joker to 5 existing cards, so you can probably just comment this out because it never happens.
Yeah.
If you have a 4 of a kind, it upgrades to 5 of a kind. A full becomes 4 of a kind, and because we have 3 and actually this also never happens because a full is already 5 cards, right? Yeah, so it was a bit of an overkill, but 3 of a kind actually becomes 4 of a kind, 2 pairs become a full, 1 pair becomes 3 of a kind, and a high card.
Formatting thing here, but yeah.
Mm-hmm. Oh yeah, sorry.
My bad. Yeah. Cool. Okay.
Are you just gonna keep those now? Well, I sure broken something. Is that better?
Cool. Not particularly. Let me just reopen this file. I think that might just be the case here. And we'll go back to where we're at. Okay. Either way. So is this actually everything that needs to be done?
Yeah, so I think that's all of the upgrades. And yeah, so I've used the same type logic to get the base strength. And then we did the upgrades.
Wow. Okay. Yeah.
And this actually worked.
That's neat.
I have to catch up on chat, but hopefully.
Yeah.
But there's a lot of ideas in chat.
Okay, let's hear it.
Okay, this is still the first part. I just transferred all J's to 1, as 1 was not used. That makes a lot of sense. We had the 1 there all along.
Yeah, look at that. That's a good point.
It's a good thing that straight flush and straight were not included in the scoring, because that would have made brute forcing a lot harder.
Huh.
Yes, I'm also happy that we didn't have to consider colors.
Yeah.
But maybe day 20,
Who knows?
Come back to the camel.
Well, we gotta get back somehow, right?
Maya says she swapped out the jokers before figuring out the rank, but kept the jokers in the hand.
Interesting. And then the swap choice was based on the number of card that had the highest number in the string. That's a pretty good, like, heuristic, I would say.
Yeah. Also, upgrading with jokers is a simple replacement. A high card with one joker can just be a pair, and so on and so on. Yeah. So this, someone agrees that this code works.
Elegant moves. Yeah.
Someone followed the same approach. I don't know if they are replying to the chat or to this solution. What if you have 5 jokers?
0
Actually, you do have 5 jokers. I think
you absolutely do.
I don't know.
100% do.
Yes, that I think that was probably part of everyone's input.
Yes. So. Yes, there is absolutely 5 jokers.
Yeah. So of course we would get an input which has 5 jokers. So for
this is actually like when I opened the problem statement, I was like,
of course,
I'm gonna take a look here. Like, are they gonna do this one to me?
Yeah, I did a bunch of print line debugging while I was adjusting things in my code.
Yeah.
And because I was sorting ascending, the last print lines when I was printing out my whole list would contain that string with the 5 jokers. So I was like, there it is.
Yeah, I thought, because I thought about this when I did the or when I first had this idea of, can I just replace this, like Maya said, can I replace it with the highest card in my hand?
Yeah.
And it's really tempting, like, once again, if you forget about this note that it's actually ranked the lowest here, it's like, okay, cool, it's 5 cards, like, it trumps everything, like, we'll do ace, like, we'll do aces across the board. That's obviously not what gets you to the right solution, but it's an easy trap to fall into.
Yeah, there's a bunch of comments about 5 jokers still. Maya says mine crashed on 5 jokers.
Yeah.
Yeah, it would be strength 5, but the lowest in the group of 5s.
Yeah, exactly.
Because jokers are now the lowest ones. Yeah. Yeah. So 5 jokers. For my solution, I think I got lucky with 5 jokers, because if you hop back over here, I think I would just have a high card for 5 jokers. Oh, actually, so we do need to keep these things in here. The things I commented out, at least the first line. Because I think this would give me, I would go to the else branch here when determining the type up here. So it would show that I have just a high card because nothing else was true. So I would then proceed to upgrade the high card 5 times using jokers.
Okay.
So I do need to actually keep this. We can probably leave out the fool. That's your solution. Sorry. Yeah, so this can be removed, but this should crash on 5 jokers, which it does.
Look at that.
Yeah, so it wasn't that silly to have the 5-to-5 mapping after all.
Are you ready for my solution?
Yes, I think we've exhausted this one.
This one's gonna, so very clever. Now, I always prescribe to the philosophy of why would you have to be clever if you can just be slightly less clever and let the machine do a bunch of extra work. It's a great philosophy to subscribe to.
But you also said earlier that just brute forcing will not solve the problem.
Yes, so there's a mix in here somewhere.
Okay. Let's see how you've mixed that.
So let's start out. First of all, everyone's favorite function or property, the card types, now has a J string in the beginning, which properly gets flat mapped. So that's great. You'll also notice that I actually did clean up a bunch of my code here, and instead of relying so much on this weird sorting and then finding cardinality stuff, all of these are just grouping by now. There's still a bunch of like repeated code in here, but like there's a couple of slight differences that you have to make every once in a while. So I decided I'd not abstract that out, just because I figured it was a little simpler if I ever had to go and read this solution again, which I have to do right now.
Oh, and you also went from functions to properties.
That's right. And I also went from like the property accessors to just the actual property initializers, because all of this like it's an inherent property of the hand or the play or however you want to call it. So there's no need to recompute it every time you look at a comparator.
Of course, a lot of these won't be computed, or well, all of these will be computed, but you could like make them lazy if you wanted to optimize. And
sure, 100%. If I wanted to optimize, I could probably not do whatever I'm doing in the solution in a second, because you'll notice that a lot of these, or actually all of these implementations, start with a weird predicate, which is cardTypes.any. So I decided I'll introduce a function called withJokersAs.
it.
Yeah, which replaces the joker with just another character, right? So like quite literally, it does that. So in my cart here, what I essentially do is, can I find any replacement where this predicate will be true? Like, can I replace my jokers so that I'll still get 5 of? Can I replace all jokers so that I get 5 of a kind? Or can I do the same thing with 4 and so on? So this is why this pattern is the same here. Is this the most efficient? By far, it isn't, because I'll have to go through all of my, like, as we've seen, 13 different values. But again, like, back of the envelope math gives you like, okay, so you do a couple of extra, you do 1,000 operations here, maybe you do like 14,000 operations instead. All of this still runs within like on the order of milliseconds. So I'm like, I don't need to be much more clever here.
And we only have 1,000 plays that we do this with. So
yeah,
if we had 1 million, like maybe we would have to start thinking about these things. But
yeah, but at this point I was just like, well, this is code I can understand. This is code that works, and I believe that's pretty much everything. The only change that I did make was is I introduced the card counts with replaced jokers function, which you just see that where I'm. All right, I'm not using that one anywhere. This was actually the this one I don't use anywhere, because I figured we could of course make some kind of abstraction here where at the very least you don't always run over like a whole collection, but instead you only run over like a certain part of it. So instead of always taking a hand, converting everything, converting the hand to jokers, then grouping, then counting, you could do the same thing just in a sequence, rather than like looking at all the different implementations, and that might maybe make it a little bit faster. But also, But
this was also not necessary, so...
No, it was absolutely not. This was, again, just me being like, maybe this is where I could use a sequence.
So this is sort of a brute force solution, but also...
Well, it's like a brute force in the small.
Yes. So it's quite interesting that just trying to substitute the same character for all jokers each time is a correct solution.
Yeah.
So like you have to think that through. That
yes, exactly.
That you can't get stronger hands by using some jokers as this type of card and some other jokers as another.
Yes.
Type.
So this is something where like you hold on for like a couple of minutes in the morning. You're like, hold on, is that a correct invariant? And then you realize very quickly that since you're just trying to build ever bigger groups, that's the case.
Yeah, so it's a really good thing that we don't have straights and.
Oh yes, very much so. Again, like you predicted, then we would be in a little bit more trouble in this whole situation. Cool. What does chat say to this one? Yeah.
That we're just doing 13,000 tries if we have 1,000 cards, which sounds fine.
Yeah. Exactly. You have like 13,000 operations in total.
Yeah, requires more code, but not brute force. I'm not tracking all of the replies, but
that's perfectly fine. But yeah, I mean, I really like this. I always like having guests on here. I really think this show would be very boring if it was just me. So thank you, first of all.
I think you would put in a good show.
Yeah, but then I'd show people like this, and they'd be like, "What's wrong with this guy?" What's this? This is what he considers idiomatic Kotlin. Where's the folds? Where's
the folds? Indeed.
I did implement comparable. I didn't see you do that, so you know.
That's true. And we can probably, I mean, so obviously in both solutions we could start optimizing a bunch of things if we wanted to. So here you could add a bunch of lazy calls. If you go back to look at my solution, the most glaring thing that I know that I left in there is that within this sorted with call, I pass in the comparators, and those will be invoked every time that two values need to be compared. So for example, for each hand of cards, however many times we compare that to another hand, we would run the code to determine its type.
Okay.
Or we would map it into an alphabetical string.
No caching whatsoever going on here.
Yeah, and these could just be computed and stored within the hand.
Yeah.
But again, we have such a very small and convenient data set here to work with that we don't really have to think about any of these things. I think we got lucky today.
I think so too.
The problem.
Which makes this, you know, it's a little bit more of a just casual fireplace chatting set, actually. Yeah, maybe pull that one up again and slightly bigger. Have a couple of people here. Maybe see the wonderful place that we are spending our evening in today and coming to you live.
Live from Munich.
Live from Munich.
That's the way to say that. Right?
There's a winter wonderland outside, and I guess it was the perfect travel-sized puzzle.
It was great.
Now,
we have a comment I want to highlight here, which says, "Thank you for these streams," which goes to you, I think. Motivated me to refactor my KMM demo and reduce the number of I didn't read the whole thing.
In reducing the number of immutables.
Mutables.
I assume.
Next comment.
Okay, there we go. All right. Fair. That's awesome. Yeah. And if you want to go like really crazy in immutables, you can also check out the Kotlin X immutable library, which gives you two very cool interfaces: immutable collection and persistent collection. And that's maybe also something that might be interesting to you, just to explore on your own time there.
Quick shout out to another message. New Fleet version is out.
New Fleet version is out. Let's go.
Which is true. So we are on 127 here, but 128 is now available as a public release.
Look at that. That must have happened pretty recently.
Go and get that.
I certainly will.
I meant in general, but
oh,
you can get it as well.
I thought you were just like, please, for the love of everything that is Advent, just like you need to
upgrade.
You need to keep up with the times.
I think you already were on 128, and someone commented on it on an earlier stream.
Yes, I believe so. Yeah, and the answer was wait a little bit, and I guess the wait is finally over. This is the current like door of the Advent calendar on our side is I guess the new Fleet version and Kotlin for WebAssembly becoming alpha. Those are both, I think, quite cool topics. Yeah.
You know what I've just realized at the perfect time? Our names should be swapped on the stream.
That is very correct.
We have them the wrong way around.
So you'll get to take credit for all the previous streams. Look at that.
That's a good thing to fix an hour and a half in.
If you don't know us by now, yeah, I feel like we've all grown a little closer over the last 1.5 hours. I'm curious, Martin, do you have predictions for what's going to happen next?
I'm waiting for the graphs. I haven't had to build graphs yet. I haven't had to find shortest paths in them.
Yep.
Where are they? Like past day 10, maybe?
Guess we'll see. Yeah. I'm still, I mean, it's kind of related. But I am looking for some something where you need recursion. Seems
some like float filling or something. The 2D things didn't require too much like 2D grid processing yet either. We had some 2D coordinate sort of things, but they weren't too heavy, so we can easily see more of that.
Not so many situations where we had grids that wrap around and do other weird things.
Indeed.
Snakes moving or multiplying or playing a short version of Game of Life.
Yeah, I guess we've just had an embedded game within our puzzles. So we've just played poker.
Yeah.
I bet we can also find something that like actually forces us to play rounds of a game in a more like algorithmic way.
Yeah. And I'm sure there's going to be a brutal part 2 where you'll once again have to exploit some kind of great property of that game that'll cost me a Saturday morning, as it usually does. So far, I think a lot of people have commented on this. The difficulty level seems to, at least for a while, have followed this kind of sinusoid pattern, where it's like just one day it's pretty hard, the next day it's pretty relaxed, and so on. With this day in mind and with the recent days in mind, do you feel like the pattern still holds?
I think we've just broken it today. This should have been a harder one.
Do you think this is like a self-correcting type thing where it'll just completely overshoot tomorrow?
I think day 15 might be to correct the pattern.
Okay, well,
just design a thing that creates puzzles that fluctuate nicely. Because there's an elf who just loves puzzles.
Oh yeah, that would be fun.
on Puzzle Island, probably.
Probably on Puzzle Island, yeah. What islands do you think, dear viewers, are we gonna land on next? What have we been on so far? We've been on Island.
Island is probably the most important one of all.
Probably also the best one. Yeah.
So we've had Island. Then we had the green one. I don't remember what the green one was. And right now we're on Desert Island, of course.
That makes sense. Was it Snow Island? Water Island? I don't recall.
Oh, and of course, next up we'll have to fix the machines that filter the sand, because we've never done that.
Oh!
We were just told that we need to fix that.
That's a very good point.
And we're on our way on a camel.
Okay.
And this was just passing time. So it really was the calm before the storm, as people in the chat were saying.
Fixing machines, huh?
This was a traveling problem.
It was quite literally a
very
traveling
literally
problem.
That just occurred to me.
What a delight.
I could not have traveled on a better day. That's excellent.
Yeah. Well, I'm very, very interested what fixing a machine might look like. We have a couple of islands here. Kotlin Island.
I like that one.
Yeah, sounds great. Not sure what kind of puzzles we have on here. Yeah.
Definitely no Java Island.
I mean, if that's the public opinion.
You have no stance on Java Island.
I have no stance. I've never been.
Me neither. But if the elves take us there, maybe.
I mean, we'll go wherever the journey takes us.
Wherever the camel takes you, as they say.
Yeah. I do like Sky Island. That one I feel like might eventually happen. Like, we've already been fired not through cannons but through trebuchets. So I mean, what's a little more Sky?
Yeah. After that kind of a start, I think we're up for anything.
We really are. Wonderful. Well, I think that concludes our stream for today. Thank you so much, as usual, for tuning in, for deciding to spend your time with us. Whether it's your evening, your afternoon, your morning, or your night, I suppose. We hope that you enjoyed yourself. I did.
I did as well.
This was a good time.
This is really nice.
And tomorrow, we will be back, or I will be back, with another guest. And hopefully, if you're interested in, we'll hopefully also see a little bit of Kotlin for WebAssembly tomorrow. So if you're interested in what might happen in that area, make sure you tune in again tomorrow as well. But it is happening at a much earlier time. My time zone, I believe it is, I don't want to say anything wrong here, so let me just double check that. It will happen at 15:30 in my time zone. And if you, just check out on YouTube, make sure you can click the notify icon and you'll also get a small notification. Great. Then I, of course, wish you the best of luck with all the upcoming puzzles. And I do hope that we will see you again in one of the future streams. Take care, everybody. See ya.
Bye.